Right, and but by the way, so we tweet the hashtag is surprisingly enough data-driven NYC. This was a nice conversation going on, and also check if you have questions that I can ask. I'm happy to do that as well. Next up is Tobi from Mesosphere. Thank you for being here.
Yeah, thank you, Matt. It's great to be here and be speaking in front of such a high quality audience. So what I want to talk about today is I want to give you a quick introduction to the Mesosphere stack, which is basically a couple different open source pieces that we're working on at Mesosphere, and how you can leverage that if you're working in big data. So just a little background on me. Who am I? I'm co-founder CTO at Mesosphere. Before that, I was at Airbnb pretty early on. I was a tech lead and worked on a lot of infrastructure projects there. And before I joined Airbnb, I did some grad school work with sentiment analysis. And I worked with, I called it bigger data because at the time in that community, it was considered a lot of data, but it was actually not that much data. So that's my background. So why should you care about all this stuff? I think if you're doing something in big data today, you're usually running a multitude of tools. It's no longer just one tool to rule them all. You're using a couple different tools like Hadoop and Spark and whatever. And Mesos can really serve as a platform to run all of these tools as kind of the infrastructure that sits underneath them. If you're developing a new big data tool in-house, something custom, you can leverage Mesos sort of as an SDK for building those tools, because building a big data tool today means building a distributed system, and Mesos makes that really easy. The last point is kind of tuning clusters. Like if you're running really thousands of machines, you have to kind of make sure everything runs efficiently. And doing that manually is a lot of work. It's really hard. People don't like to do it. And one thing that Mesos does is it automatically bin packs your applications onto the infrastructure that you have, so you get the highest utilization out of it. So I kind of want to just talk a little bit about the background, kind of how did we get here. So back in the days when what I called the client-server era, the way we ran applications in the data centers, we had fairly big servers. We had a virtualization layer, we were running VMs on top of those to run multiple applications per physical machine typically. Because at the time, the apps were fairly small compared to the servers. But that's changed, and we're running a lot of distributed systems like Hadoop and distributed NoSQL databases today. And now you no longer have the problem of how do I run multiple apps on one machine. You have an app that runs across many, many machines, and what you kind of want to do is the opposite of virtualization and aggregate all the resources together. And Mesos provides an abstraction just like that. So just to give a little background, where is this all coming from? Mesos was, just like a bunch of other technologies that we use today, originally started as an idea at Google. And so MapReduce, for example, was started as Google wrote a paper about it. Then there was an open source implementation, Hadoop, and there's companies that support it today, like Cloudera. The same thing happened with NoSQL. There was a paper first, there was Cassandra and a couple of other NoSQL databases, and now there's companies to support them. And kind of the third wave of technology that comes out of Google is what we're working with, and we're calling that the data center operating system. Some Google engineers wrote a book. It's called The Data Center as a Computer. It sort of lays the foundation for how they think about that stuff. And then Mesos started in 2009 as a research project in Berkeley. And Mesosphere is kind of the company for it now. So if we talk about this as a data center operating system, what does that mean? If you're looking at your traditional open source, operating stack, you have operating system stack. You have a kernel, Linux, or say BSD. You have a bunch of system services like init or upstart or systemd to run your apps, and then you have your applications on top. Say Apache, MySQL, Memcache, and so on, or your Unix application. So the equivalence of those pieces in the Mesos operating system for data centers is you also have a kernel, and that's Mesos. That's really what Mesos does. You have an init system or your system services. This is Marathon. And that thing launches all your other apps like Redis or whatever you have. And to zoom in a little bit more and talk about the details, so you have the hardware at the bottom. You run Mesos on all the machines as a kernel. And Mesos gives you different APIs that you can use. So it gives you an SDK for building distributed systems, and you can build those in Java, Python, C++, Go. There's actually more language bindings now. And you can build applications against that API or port existing applications. And we call those native Mesos apps. And examples for those are a lot of the big data tools that you're probably familiar with, like Spark and Storm and Hadoop and so on. And in fact, Spark, this is a little known fact, Spark was actually the first application that was ever built on top of Mesos, and it was sort of the demo app for Mesos in the beginning. There's another API, kind of the Marathon init style API. It's Marathon provides a REST API, so you can run anything that's long-lived, anything you want to keep up and running forever. And there's a third API, which is called Kronos. It's also a REST API, and it lets you do anything that kind of cron-type workloads, run this at certain intervals. And it's pretty sophisticated, and I'm going to go into more detail in the end of the presentation. So Mesos as a distributed operating system kernel, what does it actually give you? If you really zoom in and talk about the details. So it's a cluster-level resource scheduler, meaning it knows about all the resources in your cluster, all the CPU, memory, disk, everything else that's available, and it schedules the applications that you want to run in the cluster. So if you have competing applications, like Hadoop and Spark, they all want resources. Mesos makes sure that everybody, gets a fair share and that they can all run in parallel. Mesos lets you launch tasks across the cluster. That's one of the fundamental building blocks for a distributed system is you just want to start something somewhere in the cluster, and Mesos gives you an API to do that. It does failure detection. So when you lose machines in your cluster, when processes die, all sorts of different failure scenarios, Mesos will notify the applications when that happens. There's also communication between different tasks that you launch on Mesos. You can send messages back and forth. It's a little bit like IPC in the process communication. There's a distributed state abstraction, so you can store any kind of metadata, any working set that you need to keep persisted. And all that is kind of packaged up in an API for building what we call native apps. And there's language APIs in a couple different languages. And what this really gives you is that when you build a custom framework, a Mesos native application, it becomes elastic pretty much from the get-go. So as your application requirements change over time, your applications can automatically make use of additional resources as they become available in the cluster. Meaning, if you need to scale up, all you have to do is add machines to the cluster. And then the applications can automatically leverage those. And it does easy failover and HA. So Mesos itself is highly available. You can kill any single component in the system, and it'll keep running. It'll fail over. That's one of the most fundamental principles in Mesos. So Mesos is, it started as a research project. It was adopted by Twitter just about a year after it started, and Twitter really put a lot of effort in making it production grade. And so today, it scales to tens of thousands of nodes. It actually runs, it's the basis for most of Twitter's production infrastructure today. It's a top-level Apache project. And Mesosphere, Twitter, and Airbnb are major committers on the project. There's a couple more, too. And lately, since the last Mesos release, we also have built-in containerization. So we have support for Docker. Mesos can run Dockers out of the box, and so you can put your applications in a Docker and contain them that way and ship them easily. So frameworks, or that's what we call the applications that are running on top of Mesos. And those are some of the most popular ones, and all the stuff in green is sort of stuff that falls into the data infrastructure space. So Hadoop runs natively on Mesos today. MPI, Spark, Storm, and a couple of other things that might be less well known. Exelixir is a distributed neural network in Python that runs on Mesos, and you can run Cray Chapel on it too. There's a lot more actually in the community. We've seen a lot of those getting created lately. So I want to talk about how we used Mesos at Airbnb and what it really gave us, kind of every day. So Airbnb data infrastructure 1.0 was pretty boring. It was MySQL and Stata. It ran on one machine, and it was kind of limited. There was one analyst who did all this stuff in the beginning, and as soon as there was a second analyst, this all fell over, and there was too much data to deal with. So pretty quickly, switched to Hadoop, and I called it a handcrafted Hadoop cluster because we had to set it up in-house. There was not much support available at the time. And a couple different pieces, Flume, HDFS, Hive, Pig, pretty typical for a big data stack. It's like all these pieces, and you wire them together. A lot of these pieces were pretty young and unstable, for example, Flume. And so it was really challenging to keep the cluster healthy and up and running because the team was very small. So we made some changes to this. And so infrastructure 2.5 was we used AWS Elastic MapReduce, so we no longer had to manage the Hadoop cluster ourselves. We built a custom logging system to replace Flume. And we also added a bunch more tools. AWS came out with Redshift, which is the analysts really like, makes it really easy to query your data. People started using cascading Cascalog, so a lot more tools to the mix. The big problem at this stage was that all the orchestration still happened from a centralized cron tab. So there's always multiple steps. First you start with dumping some of the data in your SQL database. You get your logs together. You run multiple steps in your data pipeline, and then you publish the results somewhere. And all that orchestration was really done with a central cron tab, and it broke all the time. The syntax is horrible. People made mistakes. If the machine failed, nothing would run, and everybody was pretty unhappy. So how did we fix that problem? That problem we fixed by building a new distributed system called Kronos that runs on top of Mesos, and that was sort of the first use for Mesos at Airbnb. And here's a diagram of what it looked like pre-Kronos. Like I just said, you had kind of have cron orchestrating all the different pieces in the system, dumping the data from the different data stores into HDFS and then running all the steps. So, and what it looked like was you basically had this huge dependency graph. All these different steps that depend on each other, and God forbid one of those steps fails, everything would fall over. So, this is actually what the cron tab looked like. Yes. So, problems with this approach. Tens of thousands of lines of cron and bash. This is horrible. Sleep 300 to basically orchestrate the different steps. And if you're running in the cloud, most things are awesome, but it's not always that reliable. You get a lot of randomness in the network that you have to deal with. It's obviously not HA. If you lose that node that runs the cron tab, then nothing will work. And most of those steps are very I/O heavy. If you dump the whole production database, you're going to max out the network interface. And so if you're doing a lot of stuff in parallel, that's a real constraint, and you really need to pretty early on run this on more than one box. And yeah, debugging was really hard. Nobody knew when things went wrong, why they went wrong, and so people spent a lot of time doing that. So we tried to build a better system to fix that. We didn't find any of the existing tools to be up for the job. They were too heavyweight. We couldn't get them installed. So we really wanted this thing to be HA and fault tolerant, distributed, and make the debugging easy and give this thing an easy interface, a REST interface. So because we built it on top of Mesos, we were able to pull this off really quickly. It just had 3,000 lines of code, and it's elastic and HA out of the box because Mesos gives us that. My favorite fact is Kronos never, it's a distributed system, and it never opens a single socket. There's no network programming whatsoever in Kronos because Mesos takes care of all of that. So, basically the central piece is where Kronos runs. It replaces cron. It's distributed and fault tolerant now. It also has a really nice user interface. It was used by data analysts, and they like these interfaces. So what does it look like today? Airbnb actually added even more tools to the mix, and their data infrastructure is really a pretty complex setup today. So they're running Kafka and Cassandra and Presto, which is a SQL query engine out of Facebook. And they're running most of these data tools on top of Mesos, either as a framework directly like Kronos or like Hadoop, or they're running them on top of Marathon. And Kronos orchestrates all of the ETL at Airbnb. And what's really great is that they basically have one single person that runs all of this data infrastructure for this huge company. And they can do that because they can automate so many things with Mesos. And that's it. Thank you very much.
Thank you very much. That was great. Well, what's your impression of the sort of state of readiness of the market for something like this? Or, Airbnb is one of those awesome valley companies that's both young and growing exponentially and more likely to experiment. And I guess to give some context, like how big is the Mesos community? How many people actually support this?
Yeah. So when we started the company early last year, there was, I think, 4 companies that were using Mesos. It was Twitter, Airbnb, and a few small ones. And the ecosystem has really grown a lot since then. So in the last year and a half, we've added, it's a couple dozen companies now. And I'd say today, most of the adopters are still in tech, but you see some very large tech companies, more traditional tech companies like eBay, for example, adopted. We're really excited to have them in our ecosystem. They adopted it recently. And we've also seen, we're actually seeing a lot of companies in the financial industry take it up as well. And also some, traditional retail businesses. It's pretty early for these guys, but they're playing with it as well. Yeah.
Very cool. Want to open it up to questions? And if you could start with just your name and company whenever you do get the mic.
Nick, I work for an investment bank, and my question is, Mesos provides Chronos or Aurora, Singularity, all these features out of the box. So I'm trying to understand, what does Mesosphere do actually in this case? Yes, Airbnb, Twitter are using it. Are you like one of the open source guys who contributes to Mesos? Or, I'm sorry, I'm a bit confused. Maybe a silly question.
No, this is great. So yeah, basically all the pieces, we as a company, we contribute to Apache Mesos, to the open source project. We want to drive that forward. And we also support some of the open source projects on top, like Marathon and Chronos. What we do in addition to that is, we provide commercial support, and we're working on more advanced, enterprise features for Mesos. So things in the security space and more efficient scheduling.
There's one right here. No, you had a question? Yeah. The mic is coming. Name and company, please.
Great. Hey, my name is Joe Galarn. I'm from a company called Mesobit with a Z, not an S, but share a similarity there. I was wondering, this sounds really great. So what are you seeing to be the barriers to adoption in the field? I look at this and go, this is fantastic. But clearly, even though it's kind of new, it seems like there's something maybe you're not saying regarding how difficult this is, or not.
So barriers to adoption. I think the first thing that needs to happen is sort of this paradigm shift, because it's a very different way of thinking about infrastructure. You completely forget about individual machines, and I think it's just, that shift just has to happen, that you get used to the fact that your applications will run wherever resources are available, and they may move from one machine to another. So I think that's pretty big shift, and it takes some time sometimes until people get that, and then they're all super excited. I think maybe another thing, and this is where we want to help as Mesosphere also, is it's still, it's a distributed system. It's a complex system. And so if you want to run it, you need at least some familiarity with, running distributed systems and doing operations for distributed systems, to feel comfortable operating it. Yeah.
Yep.
Hi, I'm Aaron Franco. I'm the CTO of ClickSlide. I'm just wondering how it handles, if I have my app running, I install it into Mesos, and I'm doing read writes to the native file system. Am I writing to the VM that the app is running in? Am I writing to bare metal, or am I is it automating it to S3? How is it handling that? Yeah,
so Mesos today only manages compute. We actually don't manage, state. So basically, there's a couple options. A lot of the stuff that we run on Mesos today does its own handling of state. So if you're using Hadoop, you would be running HDFS, and HDFS would take care of it. If you're running, a traditional app that uses a POSIX file system, you would be running a distributed POSIX file system on the side. So Mesos doesn't manage that today. What we're working on is we want to build primitives into Mesos to make it easier to support apps that need state on top of Mesos. So moving things like HDFS on top of Mesos instead of running it side by side, and being able to take advantage of all the stuff that Mesos provides you, but at the same time being able to handle your state properly.
Hey, I'm Dag from TapPad. So what you're describing here is kind of more like the virtualization rather than isolation. And so I'm personally excited about Mesos. Whenever I ask my ops team, though, can we start looking at Docker and Mesos, they ask me, so what's the benefit of doing isolation like Mesos does versus virtualizations, especially when a lot of the systems that you mentioned there are Mesos native, or actually systems that are built as being distributed from the beginning. Mm-hmm. Hence, you already have a concept of nodes in Storm or in Spark and whatever. So you're still thinking about virtual servers in some sense. So kind of where's the real, like the elevator pitch on why isolation is better than virtualization?
Yeah, so it's better because it's more lightweight. And if you're running stuff in a VM is basically a black box from the outside. You can't really look inside. I mean, you can get some summary statistics on the utilization or whatever, but you can't really optimize what's inside because you can't look inside. With containers or lightweight Linux containers, you can do that. And you also don't have the overhead of running the hypervisor. So for each task, you don't need to run the hypervisor. You don't need to bring up a full operating system. You're just isolating the resources. And that allows you to do things that you can't do with VMs. For example, launching quickly launching very short jobs, like jobs that will only take 5 seconds to run. You can do that if you're using isolation. It's impossible, or it's not impossible, but it's very inefficient with VMs. So yeah, and to the other part of your question, like systems like Storm, they were built in a pre-Mesos world, Storm and Hadoop, and so you by moving them onto Mesos. So of course we don't solve the problem of making them distributed, but what we do solve is we basically make it easier for you to deploy them. So setting up a Hadoop cluster is a lot of work. Setting up Storm is a lot of work. It's actually really easy with Mesos, and you can basically, as a service to your internal team, you can offer something like disposable Hadoop clusters, and it makes it really easy to experiment with it.
Great. So that's all the time we have for now, but you'll be around.
I'll be around.
Thank you so much.
Thank you.